Hi guys, welcome to Engineered Math channel. So we're live. Our topic for today is transforming matrices to row echelon form and reduced row echelon form. Okay, so by the way, I already have previous video all about row echelon form and reduced row echelon form of matrices. So if you haven't watched that yet, I will just put the link on the description because it's important that you already understand the concept or the properties of row echelon form and reduced row echelon form for you to better understand this topic. Okay? So I will just put the link on the description. I already have a detailed video on how to identify whether a matrix is in row echelon form or in reduced row echelon form. So now, we will transform matrices to row echelon form and reduced row echelon form. Okay? By the use of elementary operations. So this is important because we will apply this method when we are trying to solve systems of linear equations in n unknown using Gaussian elimination or Gauss-Jordan elimination method. So let's start first with transforming matrices to row echelon form and reduced row echelon form. So as a quick review, I wrote here the different properties or definition for row echelon form or REF and reduced row echelon form or RREF of matrices. So we already discussed this on the previous video that I told you. So a matrix in row echelon form has the following properties. All rows consisting of entirely zeros occur at the bottom of the matrix. For each row that does not consist entirely of zeros, the first non-zero entry is 1, called a leading one. 3. For two successive non-zero rows, the leading one in the higher row is farther to the left than the leading one in the lower row. And then, a matrix in row echelon form is in reduced row echelon form if each column containing a leading one has zeros in all its other entries. So, we will again use these properties when we transform matrices to reduced echelon form and reduced row echelon form. Okay, so take note of this one. Now, how do we transform any matrices or any matrix to its row echelon and reduced row echelon form? So it states here that two matrices are said to be row equivalent if one can be obtained from the other by a finite sequence of elementary row operations. So elementary row operations are the following: interchange two rows, 2. Multiply a row by a non-zero constant, and 3. Add a multiple of a row to another row. So we will use these three elementary row operations to convert or transform a matrix into their row echelon form and reduced row echelon form. So to illustrate how to use these elementary row operations, it's better to show this, to illustrate this using problems. Okay? So let's have some problems to illustrate how to convert matrix to row echelon form and reduced row echelon form. So transform the following matrices to row echelon form, or let's have REF for short acronym, and reduced row echelon form, or RREF for short. Okay, the first one, we have the matrix with entries 1, 2, -1, 2. Okay. So we have a square matrix having the same number of rows, 2, and number of columns, also 2. So this is 2 by 2. 2 by 2 matrix or square matrix of order 2. So I already have an introduction about some concepts on matrix also on the previous video, which is entitled uh, row echelon form and reduced row echelon form of matrices. Okay, so you can watch that also. Of order n, the n is 2, right? Because it is a 2 by 2 matrix. So let's start by converting this into its REF or row echelon form. Because obviously it's not yet in its row echelon form. It doesn't obey the three properties enumerated above, right? So if you try to convert this into row echelon form, what should be the final look of the matrix? Okay, if it's a 2 by 2 matrix, based on the properties of a row echelon form matrix, it should look like this: 1, 0, 1, and any value of this constant. Okay? So the goal is to transform this matrix into this form. This asterisk means any constant, whatever constant we have obtained by applying the different elementary operations. So the most important numbers that we must have here is that 1, 0, 1 for these entries. Okay? And whatever is this one is not important. So we start by making this entry, the A11, equal to 1, right? But it's already 1, right? So we don't need to do anything about this, about A11. It's already 1. So next is to make this entry, which is A21, equal to 0. So how can we make this entry equal to 0? This time by applying the elementary row operations. Okay? So applying the third property or the third elementary row operation, you can add a multiple of a row to another row. Therefore, if this is our given matrix, if we add, okay, if we transform this row 2 into its new form, such that the goal is this negative 1 becomes 0, we can actually add row 1 plus row 2. Okay? We add a multiple of row 1, which is itself 1. Okay? Its multiple itself, which is 1. Then add it with the row 2. Okay? So you can, if you can't visualize what will be the new look of R2, you can write down the operations. So you will add R1, the entries in R1 and 2, you will add with the entries in R2, which are negative 1 and 2. If you add 1 plus negative 1, that's 0, the goal, right? To make this entry 0. And then 2 plus 2, 4. So therefore, this will be the new look of R2. Okay? So this is your R1. You add this with R2. And if you operate on this, it will result to R2 equal to 0, 4. Okay? So therefore, it will become 1, 2, 0, 4 now. Okay? And this operation is R2 equivalent to R1 plus R2. Okay. We already have 1, 0 in the first column. The next goal is to make this entry 1. Okay? So far, we have this form of the matrix. So how can we make this entry, which is entry A22, right? How can we make this entry equal to 1? We can apply another elementary row operation. Particularly, Number 2, we can multiply a row by a non-zero constant. So how can we make 4 1? By multiplying it by 1/4, which is a constant, right? So therefore, the next goal here is to make this 4 equal to 1, and it can be done by multiplying row 2, by 1/4. Okay? Applying sa second, the elementary row operation. Okay? So if we do this, list down the element the entries in the second row, which is 0, 4. You multiply all these entries by 1/4. So 1/4 times 0, still 0, and 1/4 times 4, 1. So this will be the new look or the new form of R2. So this will become 1, 2, 0, 1. Okay? And the operation that we did is R2 is equivalent to 1/4 R4. So we already have obtained the REF form because we already have this form 101 and asterisk any number. In this case, we have 2. Okay? So this is already in REF. Okay? How about the next form is its reduced row echelon form. So if we want this to have its reduced row echelon form, it should be 0 here, right? Based on the property of reduced row echelon form. Sorry. Okay. So from what we have so far, we tried to reduce this 1, 2, 0, 1 matrix, the REF form, into its reduced row echelon form, which is this one. So what we need to change is just this entry, right? Instead of 2, it should become 0. So we can apply elementary row operations again. How? By applying elementary row operation 3. Add a multiple of a row to another row. So how can we obtain 0 from 2 and make it, how can we obtain the 0 from this form of matrix in this entry? How can we make this 2 become 0? If we notice that if we add, okay, we can add, sorry, R1 can be equivalent to, if we add negative 2 times R times R2 plus R1, okay? If we add the multiple of R2, which is negative 2, plus the first row here, it turns out to be that this 2 will become 0. So if you cannot visualize yet, you can write the operation. So you have negative 2 times R2. This is your original form, the REF. You multiply it with 0. You multiply negative 2 by the entries in its row 2, 0, 1, and add this with the entries in row 1, which is 1, 2. So this will become 0. You distribute this negative 2, then plus 1, 2. So you will have 0 plus 1, that's still 1. Then negative 2 plus 2, that's 0. So this will be the new look or the new form of your R1, which is 1, 0, right? So therefore, this is the RREF, applying this operation, last operation. Okay? So the answer for number 1, so REF is 1201, and the RREF is 1001. Okay, next, number 2, another 2 by 2 matrix, 2, 3, 1, negative 4. Okay, so since it's also a 2 by 2 matrix, the goal, the look for its REF is to have its form, again, 1, 0, asterisk 1, where this asterisk is whatever constant depending on the operation that we will perform. Okay, so what do you notice? The first entry is not yet 1, right? So this is the goal, to make this matrix become REF form, which is this one. So how can we make the first entry or the A11 become 1? Notice that the second row has its first entry 1, right? It's easier if you just interchange row 1 and row 2 because it's also an elementary operation, interchanging two rows, right? So I can make row interchange. I will interchange the two rows. So 1, negative 4, and 2, 3. So we have row 1 interchange with row 2. So that we already have 1 in A11 entry. Okay. So we're done with 1 here. Next. Okay. The next goal is to make this entry equal to 0. So how? Obviously, we can apply third operation again. Okay. Add a multiple of a row to another row. This time, we can do R2 equivalent to, so you will use this, the entries of this last form of the matrix. You can have negative 2 times row 1 plus R2, right? Because your goal is to make this 2, 0. If you multiply negative 2 times R1, the first entry of R1 will become negative 2. And if you add this with the first entry in row 2, which is 2, it will be 0, right? Okay, so therefore, doing this operation, okay, it's negative 2 times the entries in row 1, which is 1, negative 4. You add this with entries in row 2, which are 2, 3. Okay? But you can distribute this first. Negative 2 times 1, negative 2. Negative 2 times negative 4, positive 8, or simply 8. Then plus, copy 2, 3. So negative 2 plus 2, so it's already 0. Then 8 plus 3, it's 11. Okay? So therefore, this will be the new entries in row 2. Okay? So therefore, we have transformed this into 1, negative 4, and then 0, 11. Okay? The operation that we did is R2 is equivalent to negative 2R1 plus R2. Okay, last step. So we already have 1, 0. Next step is to make this entry, this one, equal to 1. Okay? So we can divide or we can multiply row 2 by 1 over 11 to make this 11 become 1. So if we multiply all the entries in row 2 by 1 over 11, okay, so what we have is 1 over 11 times the entries in row 2, 0, 11. Distribute this 1 over 11, we will have 0. Then 1 over 11 times 11, it's 1. So this will be the new entries in R2. So therefore, the final form will be 1, negative 4, then 0, 1. This is the REF form. Okay. Answer for REF form. Next, the RREF form. Okay. So the goal is to make this REF form becomes 1001. Okay, the RREF form. So we just need to change this negative 4 to 0, right? We can do that by adding a multiple of a row to another row. So if we did, or if we do R1 equivalent to, we should make this negative 4, this negative 4 0. So you can multiply row 2, the entries in row 2 with 4. Okay, 4 times row 2, and then you add this with the entries in row 1. Because if you multiply the entries in row 2 with 4, this one becomes positive 4. You add this with negative 4, the entry in row 1, it will become 0, right? So doing that, applying this operation, let's check. So multiply 4 times the entries in row 2, which is 0, 1. You add that with the entries in row 1, which are 1, negative 4. So we will have distribute the 4 first. 4 times 0, it's 0. Then 4 times 1, it's 4. Plus 1, negative 4. So 0 plus 1, it's 1. Then 4 plus negative 4, 0. So this will be the new entries in R1, which is this one already, right? So we have R1 equivalent to this operation for R2 plus R1. Okay? So this is the final answer for the RREF. Okay, next, number 3. What if 4, negative 3, 8, 3, 2, 23? Okay. This time, what's the size of the matrix? It's 2 by 3. 2 rows and 3 columns. Okay? So if we try to convert this into reduced echelon, row echelon form, the goal is to make its form equal to 1, 0, 1, and any constant in this asterisk. Okay? Okay. So this will be the REF form of this 2 by 3 matrix. Okay? So the first goal is to have a 1, 1 entry equal to 1, which is this 4. Originally, it's 4. Okay? How can we make this entry equal to 1? We can actually, we try to subtract. Okay, if we try to subtract, let's try to subtract row 1. So this is 4. This is 4, negative 3, 8, 3, 2, 23. If we try to, we can make an entry of 1 from 4 and 3 by subtracting. Okay? So let's say R1 is equivalent to 4, R1 plus negative of R3. R2, sorry, R2. Okay? If we do this, we will have 4, negative 3, 8, plus the negative of the entries in R2. So that will be negative 3, negative 2, negative 23. Okay? Or you can just simply subtract if you want. Okay? Or you can just do 4, negative 3, 8 minus 3, 2, 23. It's the same as this. Okay? So when we do this, 4 plus negative 3, that's 1. Negative 3 plus negative 2, that will be negative 5. Okay? And 8 plus negative 23, that will be 8 plus negative 23, 11. Right? Negative 11. Sorry. It's negative 15, I mean. Negative 15, not 11. So therefore, this will be the new entries in R1. Okay? So we will have 1, negative 5, negative 15. Okay? Then just copy this, row 2, 3 to 23. Okay, the operation that we did here for R1 is R1 plus negative R2. Okay? Which is the goal? The first goal is to make this A11 entry from 4 become 1. Okay? Next, we try to make this entry equal to 0. Right? Again, applying elementary row operation, the third one. What if we add? So for the new form of row 2, we try to add with row 2 negative 3 times row 1, right? Okay. So that when we add negative 3 plus 3, this will be 0, right? Which is the goal. So doing this operation, we will have, we will have negative 3 times the entries in R1, 1, negative 5, negative 15. We add with the entries in R2, 3 to 23. So we will have distribute first this negative 3. Negative 3 times 1, negative 3. Negative 3 times negative 5, positive 15. Negative 3 times negative 15, that's positive 45. Then add this with the entries below 3 to 23. So negative 3 plus 3, so 0. 15 plus 2, that's 17. 45 plus 23, that's 68. So this will be the new entries in R2. Okay, so therefore from this form, we will have the new entries in R2 is 0, 17, 68. And then just copy the entries in row 1, 1, negative 5, negative 15. So we obtain these new entries in row 2 by doing the operation negative 3R1 plus R2. Okay. Last goal is to make this entry equal to 17. Okay. I mean this entry 17 equal to 1 to make this 17 equal to 1. Okay? We can do that by simply dividing this row 2 by 17. Right? Okay? 1 over 17, I mean. So to make this entry 1, this 17, we multiply row 2 by 1 over 17. So that we will have 1 over 17 times all the entries in row 2, 0, 17, 68. Distribute this 1 over 17. So 1 over 17 times 0, it's still 0. And 1 over 17 times 17, it's 1. 68 over 17, is it exact? Okay, it's 4. Right? So therefore, the new entries in row 2, so this will be the new entries in row 2, it will become 0, 1, 4. Then copy the first row, 1, negative 5, negative 15. Okay, so this is now the REF form. Okay, REF form. The last form is its reduced row echelon form. Reduced row echelon form, or REF. So from this REF, how can we make this in RREF? Okay. So the goal is to make this REF look like 1 0 asterisk 1 0 1 0 0 1 asterisk asterisk. Okay. So whatever value we can have here, depending on the operations that we will form from its REF. But the goal is to make this 1001 appear in the RREF form. Okay? So, the last thing that we need to do is, from its REF form, we transform this negative 5 to 0. Okay? We can do that by applying elementary row operation, which is adding a multiple of a row to another. So, if I try to make row 1 equivalent to its entry negative 5, to make it 0, from these entries, I can multiply 5 times R2, okay, then plus R1, so that this entry will become 0. So doing that, we have 5 times, multiply 5 by each entries in R2, 0, 1, 4. Then add with the entries in 1, which is 1, negative 5, negative 15. So let's multiply first. Okay, 5 to every entry. Why did I put, okay, correct. So 5 times 0, 0. 5 times 1, 5. Then 5 times 4, 20. You add this with these entries in R1, which is 0, negative 5, negative 15. Positive 1, I mean. Positive 1. Okay. So 0 plus 1, 1. 5 plus negative 5, 0. And then 20 plus negative 15, positive 5. So this will be the new entry in R1. Okay. So therefore, from this REF form, it will become, okay, the new entries in R1 will be 105. Then copying the same entries in row 2, 0, 1, 4. Okay, so this is the REF of the matrix. Okay, so this is the REF and this is the RREF. Okay, next. Number 4. What if the matrix is 3, negative 4, 0, 2, 1, 33. Okay, again, just like on previous problem, the size is 2 by 3. 2 rows and 3 columns. So its REF form will be the same as, so 1, 0, 1, and then asterisk, asterisk, asterisk. Whichever number we have obtained from elementary operations. Okay? So the first goal is to make this entry equal to 1. Okay? Notice that we can create 1. We can create 1 from the entries in row 1, 3, and in row 2, 2 by subtracting, right? Just like on previous problem. So we can make the new entries in R1 equivalent to, so the operation that we will perform is R1 plus negative of R2. Or we just simply subtract the entries in R1 minus the entries in R2 to create 1 here in the A11 entry. Okay? So doing that, we will have the entries in R1, copy, 3, negative 4, 0, plus the negative of the entries in R2. So you just multiply each entry by negative 1. So this will become negative 2, negative 1, and negative 33. If you add this, 3 plus negative 2, that's 1, the goal, right? Negative 4 plus negative 1, negative 5. And 0 plus negative 33, negative 33. So this will be the new entries in R1. So rewriting the new form, we will have the new entries in R1, 1, negative 5, negative 33. And then copy the entries in R2. So 2, 1, 33. Okay? Next, we try to make this entry become 0, right? So again, if we try to do the new entries in R2, applying the operations, so if we multiply negative 2 times R1 plus R2, right? So that the entry here will become 0. Okay? So we need to multiply negative 2 times the entries in R1, which is 1, negative 5, negative 33. Add this with the entries in R2, 2, 1, 33. So distribute first this negative 2, multiply each term. So negative 2 times 1, negative 2. Negative 2 times negative 5, positive 10. Negative 2 times negative 33, positive 66. Add with 2, 1, 33. So negative 2 plus 2, 0. 10 plus 1, 11. 66 plus 33, 99. So this will be the new entries in R2. Therefore, we will have the new entries in R2 equivalent to 0, 1, 1, 9, 9. Then copy the entries in R1, 1, negative 5, negative 33. Okay? The next step is to make this entry equal to 1. Okay? We can do that by simply multiplying row 2 by 1 over 11, right? So that we will have 1 over 11 times all the entries in R2, 0, 1, 1, 99. Distribute this 1 over 11. So 1 over 11 times 0, 0. 1 over 11 times 11, it's 1. 1 over 11 times 99, it's 9. So this will be the new entries in R2. Therefore, the final answer for REF is, so the new entries in R2 is 0, 1, 9. And then copy the entries in R1, 1, -5, -33. So this is the REF. Okay. By the way, I I would like to take note, REF can have different forms. Okay, it's not unique. So you can have your answer. You can have another answer in REF because it's not unique. But the reduced row echelon form or RREF is unique. Okay. So next, let's convert this REF to RREF. So its RREF will be same on the previous problem. It should be 1001 asterisk asterisk. Okay? This asterisk again can be any other value, any constant value depending on the operations that we will perform. So the final step is, because we already have this REF, the final goal or step is to make this entry -5 equal to 0. Okay? So how can we make that -5 equal to 0? If we apply the operation, so the new R1 will be, you multiply 5 times the entries in row 2 plus the entries in row 1. So that you can have -5 plus 5, 0. Okay? So doing this, we will have 5 times the entries in R2, this one, 0, 1, 9, then plus the entries in R1, 1, -5, -33. But let's multiply first 5 to each entry here. So 5 times 0, it's 0. 5 times 1, it's 5. 5 times 9, 45. Then add with 1, -5, -33. So 0 plus 1, 1. 5 plus -5, 0. And 45 plus -33, it's 2, 1. Okay? 1, 0, 12. Okay, so this is the new entries of R1. Therefore, we have transformed this REF into its RREF form as, so the new entries in R1 will be 1, 0, 12, and then copy the same entries in R2, 0, 1, 9. So this is the RREF form. Final answer. So RREF form again is unique. You cannot have more than one value of RREF. But for REF, it's not unique. You can have another set of value for REF. Okay, next. Problem number 5. What if the matrix is 1, 2, 3, 4, -5, 6? Okay. So again, the size is 2 by 3. 2 rows and 3 columns. So what will be its REF form? So same on the previous two problems. It should be 1, 0, 1, then asterisk, asterisk, asterisk. So again, these asterisk are any constant number depending on the elementary operations that we will perform. So the first goal is to make this entry equal to 1, which is already 1, right? So we're done with this entry. We don't need to do anything. Okay? How about this 4? We need to convert this to 0. So we try to apply elementary operation. So the new row 2 is equivalent to make this 4 0, okay, we can multiply -4 times R1 plus R2. Okay. We add the -4 multiple of R1 with R2 to create the new form of R2. So doing that, -4 times the entries in R1, which is 1, 2, 3, plus the entries in R2, which are 4, negative 5, 6. So we multiply first negative 4 to each entry. So negative 4 times 1, negative 4. Negative 4 times 2, negative 8. Negative 4 times 3, negative 12. Then add with 4, negative 5, 6. So negative 4 plus 4, 0. Negative 8 plus negative 5, negative 13. Negative 12 plus 6, negative 6. So this will be the new entries in R1, R2, sorry. R2. So therefore, we will have, okay, the new entries in R2, 0, negative 13, negative 6, and then copy the same entries in R1, 1, 2, 3. Okay, next. So we're done with 1, 0. Next is to convert this entry, negative 13, to 1. Okay. So how? We can simply multiply. Okay, so row 2 will be multiply row 2 by negative 1 over 13. Because if you divide negative 13 by, or if you multiply negative 13 by negative 1 over 13, it will become 1. Right? So doing that, we will multiply negative 1 over 13 to every terms or every entries in row 2, 0, negative 13, negative 6. Distribute this negative 1 over 13. So negative 1 over 13 times 0, 0. Negative 1 over 13 times negative 13, positive 1. Negative 1 over 13 times negative 6, positive 6 over 13. So this will be the new entries in row 2. So finally, the REF form is, so the new entries in row 2 will be 0, 1, 6 over 13. Then copy the entries in row 1, 1, 2, 3. Okay. So this is the REF. Okay. Again, REF is not unique. You can have other variation of REF. Okay. Next, what if the RREF? Okay. So the goal is to convert this REF form to 1001 asterisk 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 only, one asterisk only here, then asterisk. Okay. So we only need to convert 2 to 0, right? So by applying elementary operations again, so the new R1 will be multiply negative 2 times the entries in row 2 plus the entries in row 1, right? For us to cancel or to have 0 in this entry. Okay? So negative 2 times the entries in row 2, 0, 1, 6 over 13 plus the entries in row 1. Okay? 1, 2, 3. Let's distribute first this negative 2. So negative 2 times 0, 0. Negative 2 times 1, negative 2. And negative 2 times 6 over 13, negative 12 over 13. Right? Then add with 1, 2, 3. So 0 plus 1, 1. Negative 2 plus 2, 0. Then negative 12 over 13 plus 3. So that's negative 12 over 13 plus 3. 27 over 13. Okay. So this will be the new entries in row 1. So the final form or the final RREF will be, so the new entries in row 1, replace this with this one. So 1, 0, 27 over 13. Then just copy the same entries in row 2. 0, 1, 6 over 13. So this is the RREF. Final answer. Again, this is unique. We should have any other RREF. This is just the RREF. 1027 over 13, 016 over 13. But the REF can be any other entries. Okay? It depends on the operations, elementary operations that you did. Okay, next, number 6. What if 1, 2, 3, 4, 5, 6, 7, 8, 9? Okay. This time, the size of the matrix is you have 3 rows and 3 columns. So 3 by 3 matrix, or it's actually a square matrix of order 3 because we have the same number of rows and columns. So square matrix of order 3. So if we have a square matrix this time of order 3 or 3 by 3 matrix, what is the look of its REF? So it should have 1, 0, 0, then 1, 0, 1, and any other constant in the asterisk. Okay? So again, if you're confused why is this the required REF, you go back to my video because I explained in that video in entitled the row echelon form and reduced row echelon form of matrices. Okay, I explained there the forms of REF and RREF of matrix. Okay. So if it's 3 by 3 matrix or a square matrix of order 3, this is the REF form, the pattern for REF. Okay? So the first goal is to make the first entry A11 equal to 1. Okay? Which is already 1, right? So we don't need to do anything. Okay? Next. Okay, let's try to make this entry 0. Okay? So you notice the flow of our operations, or the order of how we transform the matrix into REF form. We start with the first column. Okay? We make this 1, 0, 0, and then on the second column, we make 1, 0. Okay? And on the third column, we make 1. Or it depends on the size. So we always start in the first column, then on the second column, and then on the third column. Okay? So how do we make this entry for equal to 0? So applying elementary operations, which is, so if we copy this one here, let's copy so we have more space. So if we have row 2, equivalent now to, if we multiply -4 times row 1, and we add this, and if we add this with row 2, we can cancel out this 4, or this 4 will become 0, right? So we have -4 times the entries in row 1, which is 1, 2, 3, plus the entries in row 2, 4, 5, 6. So we multiply first each term by -4. -4 times 1, -4. -4 times 2, -8. -4 times 3, -12. Then plus 4, 5, 6. So add -4 plus 4, 0. -8 plus 5, -3. negative 12 plus 6, negative 6. So this will be the new entries in row 2. Okay? So we have the new entries in row 2 will be this one, 0, negative 3, negative 6. Okay? Then copy the first and the second row. 1, 2, 3. I mean the first and the third row. 1, 2, 3, and 7, 8, 9. Okay, next. Make this 7 equal to 0. Okay? So if we try to have the new form of R3 equal to negative 7R1 plus R3, we can make this entry 0, right? So we have negative 7 times the entries in R1, 1, 2, 3, plus R3, which is 7, 8, 9. So distribute the negative 7. Negative 7 times 1, negative 7. Negative 7 times 2, negative 14. Negative 7 times 3, negative 21. Plus 7, 8, 9. Okay, so negative 7 plus 7, 0. Negative 14 plus 8, negative 6. Negative 21 plus 9. Okay, we have negative 12. So this will be the new entries in R3. So therefore, we have the new entries in R3, 0, negative 6, negative 12. Then copy the first two entries in row 1 and row 2. So 1, 2, 3, 0, negative 3, negative 6. Okay. So we already done with 1, 0, 0 here. Okay. Next is to make this entry equal to 1. Right? This one, the negative 3. So we can just divide both all the entries in row 2 by negative 3 or multiply. So row 2 will be, you need to multiply negative 1 over 3 by the entries in row 2. Okay? So doing that, we have negative 1/3 times all the entries in row 2, 0, negative 3, negative 6. So multiply each term by negative 1/3. Negative 1/3 times 0 is 0. Negative 1/3 times negative 3, positive 1. Negative 1/3 times negative 6, positive 2. So this will be the new entries in row 2. So we will have the new entries in row 2 is 0, 1, 2. Then copy the entries in row 1 and row 3. 1, 2, 3, 0, negative 6, negative 12. Okay? So the next goal is to make this entry equal to 0. Right? Okay? So we can do that by using row 2 and row 3. Okay, the new row 3 can be equivalent to 6 times row 2 plus row 3, right? So that this negative 6 will become 0. So 6 times the entries in row 2, 0, 1, 2, plus the entries in row 3, 0, negative 6, negative 12. But let's distribute first this 6. 6 times 0, 0. 6 times 1, it's 6. 6 times 2, it's 12. We add with 0, negative 6, negative 12. Okay, so 0, 0. 0 plus 0, 0. 6 plus negative 6, 0. 12 plus negative 12, 0. So therefore, row 3 will become a 0 row because all the entries are zeros. So therefore, the new look or the new entries in row 3 will be replaced with 0, 0, 0. And then copy the entries in the first and second row. 1, 2, 3, 0, 1, 2. Okay, actually, the initial form of REF that we have assumed is not really the final form of REF. This is the original REF form that we assume for the 3 by 3, right? Because there are also instances that, let's say, for this problem, the last row turns out to be a zero rows because all its entries are zero. So we weren't able to have this expected REF form. Okay, but still, this is already in REF. Okay, if you try to apply the three properties of REF, so we don't need to make this entry become 1 because it's already 0. So therefore, it's already in REF form. Okay, already in REF form. So if we convert this into RREF, okay, the form of RREF should be, so 1 0 0 and then 0 1 0, then 0 asterisk asterisk. Okay, so this is the uh, RREF form. Okay, for this REF. So we need to only transform this to 0, right? Again, in this RREF form, these two asterisks can be any constant depending on the operations that we will perform. So we just need to perform one last row operation, elementary row operation, to transform these two to 0, right? So if we multiply the new row 1, applying elementary row operations can be, okay, multiply row 2 by negative 2. So negative 2 times row 2, we add it with the entries in row 1 so that this 2 becomes 0, which is the goal. So doing that, we have negative 2 times the entries in row 2, this one, 0 1 2. We add with the entries in row 1, which is 1 2 3. Okay, 1 2 3. So you distribute this negative 2 first. Negative 2 times 0, 0. Negative 2 times 1, negative 2. Negative 2 times 2, negative 4. Add it with 1 2 3. So 0 plus 1, 1. Negative 2 plus 2, 0. Negative 4 plus 3, negative 1. Okay. So this is the new entries in R1. So therefore, we will have the new entries in R1, 1 0 negative 1, and then just copy the entries in row 2 and row 3. So 0 1 2 0 0. 0 1 2 0 0 0. So this is the RREF. Okay, RREF. So again, this is a unique RREF. There should be no other RREF for the given matrix. Okay. Next. Okay, next. Number 7. Number 7, what if the given matrix is 2 1 3 0 negative 2 7 3 4 5? Okay. So again, this is a square matrix, a 3 by 3 matrix, 3 rows and 3 columns. So the expected REF form is 1 0 0 1, 0, 1, and asterisk, asterisk, asterisk. Okay. So let's make this entry 2 equal to 1 first. Become 1, I mean. Transform this entry 2 to 1. How? Notice that you can create a term 1, okay, from 2 entry here by what? You can have R1 equivalent to the difference of R3 minus R2, or simply R1 negative R1, okay, negative R1, or actually R3 first. So R3 is equivalent to R3 R3 plus negative of R1. Okay? We try to make first the entry here equal to 1 so that we can apply interchanging of rows. We interchange R3 and R1 next so that we have a number 1 entry in A11. Okay? So we have entries in R3, 3, 4, 5. Okay? We add with the entries in R1 times negative 1. So we multiply each term of R1 by negative 1. So we will have negative 2, negative 1, and negative 3. So 3 plus negative 2, 1. 4 plus negative 1, 3. 5 plus negative 3, 2. So this will be the new entries of R3. Okay? So the new entries of R3 will be 1, 3, 2. Okay? Then copy the entries in row 1 and row 2. So 2, 1, 3, and 0, negative 2, 7. 2, 1, 3, 0, negative 2, 7. Okay, now we can interchange. Just like what I've said, we make this one first so that we can interchange the rows, row 1 and row 3. Because interchanging row, remember, is also elementary row operations. So therefore, we can have interchanging row 1 and row 3. We make row 3 become the new row 1. So 1, 3, 2. And we make row 1 become the new row 3, 2, 1, 3. And then copy the same row 2. 0, negative 2, 7. So what we did here is to interchange row 1 and row 3. Okay. Next. Okay. So we already have 0 entry here, which is this part. Okay. We don't need to do anything there. How about, how about this one, this 2? We should convert this 2 to 0. Okay. So applying elementary row operation, we can apply the new entries in row 3 equivalent to, so we multiply negative 2 times row 1 plus row 3. Okay? So that this 2 will become 0. So negative 2 times the entries in row 1. So 1, 3, 2 plus the entries in row 3, 2, 1, 3. So let's distribute first is negative 2. Negative 2 times 1, negative 2. Negative 2 times 3, negative 6. Negative 2 times 2, negative 4. Then plus 2, 1, 3. Negative 2 plus 2, 0. Negative 6 plus 1, negative 5. Negative 4 plus 3, negative 1. So this will be the new entries in R3. Okay. So new entries in R3 is 0, -5, -1. And then just copy the entries in row 1 and row 2. So 1, 3, 2, and 0, -2, 7. Okay. So we're done with 1, 0, 0 here. Okay, next, to make this entry 1 equal to 1, which is -2 here, right? So we can, okay, we can divide this by 1, -1/2, right? So that it will become 1. But that's possible. But if we do that, there will be complexity in operations of fractions because we will create -7/2 here, right? So, alternative way to have this equal to 1 is to create 1 by elementary row operations, adding a multiple of row to another. It is possible because we have, okay, we have 3 and -2 here. Okay. We have 3 and -2 here. If we add row 1 plus row 2, this entry, 3 plus -2 will become 1, right? Let's try to do that. So let's have row 2 equivalent to row 3 to row 2 plus row 1. Okay? So row 2, 0, -2, 7 plus row 1, 1, 3, 2. Okay, so 0 plus 1, 1. Then -2, or actually it's not useful pala because we will change this entry to 1. Okay, so we can create another one by using only row 2 and 3. Okay, because if we do the original plan, this one, so 1, 3, 2, 0, -2, 7. If you add this, it will be 1, 3 plus -2, 1, 2 plus 7, 9. Right? So this will to be transformed into, this will be the new entries of R2. 1, 1, 9. And then copy the first row, 1, 3, 2, and the third row, 0, -5, negative. Although we have created 1 here, which is the goal, this entry change from 0 to 1. Okay? Which is not a good thing, right? So therefore, we cannot do this. But we can get a 1. One possibility is, okay, if we have the new entries in row 3 equivalent to, because we have -5 and -2 here. What if we perform -3R2 plus R3? Okay. We can create a 1 here. because negative 3 times negative 2, positive 6. Positive 6 plus R3, negative 5, 1. Okay, good. So let's try that. So negative 3 times the entries in R3, so 0, R2 I mean, 0, negative 2, 7, plus entries in R3, 0, negative 5, negative 1. Distribute the negative 3. So 0 plus 6 minus 21. Then add with 0, negative 5, negative 1. So 0 plus 0, 0. 6 plus negative 5, 1. Negative 21 plus negative 1, negative 22. This will be the new entries in R3. Okay. So we will have the new entries in R3 as 0, 1, negative 22. Then copy the entries in first row and second row, 1, 3, 2, and 0, negative 2, 7. 1, 3, 2, and 0, negative 2, 7. Okay. So, the goal is to make this negative 2 equal to 1. But since we already have a 1 here in the same column as negative 2, we can interchange. Okay, interchange row 2 and row 3. So doing that, we will have 1, 3, 2, 0, 1, negative 22, 0, negative 2, 7. So we interchange row 2 and row 3. Okay. Again, you can just divide by negative 2 so that you create a 1 here. But it's quite harder to operate when you had a fraction because we will have 7 halves here when we divide this row 2 by negative 2, right? Negative 7 halves. If we try to do any other elementary operations, it's harder to operate because there is a fraction. Okay? You can get rid of that difficulty if you can notice elementary operations such as adding a multiple of a row to another to create a 1, which is possible in our case because we have we have these entries in row 2 and row 3. But in case it's not possible to create a 1 from adding a multiple of a row to another, you don't have a choice but to divide that row by a constant to make that 1. It means you just need to perform operations with fractions. Okay? So next, now that we have a 1 here, the next goal is to make this 0. Right? Which is in our given, it's negative 2. So how can we make this negative 2? So the new form of R3 can be, so we multiply 2 times R2 plus the entries in R3, right? To eliminate this negative 2 or to make this negative 2 0. So 2 times the entries in R2, 0, 1, negative 22, plus the entries in R3, 0, negative 2, 7. But let's distribute these two first. So 2 times 0, 0. 2 times 1, 2. 2 times negative 22. It's negative 44. Then plus 0, negative 2, 7. So 0 plus 0, 0. 2 plus negative 2, 0. Negative 44 plus 7. Okay. That will be negative 37. So this will be the new entries in R3. Okay. The new entries in R3, 0, 0, negative 37. Then copy the entries in the first and second row. 1, 3, 2, 0, 1, negative 22. Okay. Next. The next goal is to make this equal to 1, right? Okay. That's the last step. We can make this equal to 1 by multiplying row 3, I mean, row 3 by negative 1 over 37. Okay? So, multiplying negative 1 over 37 times the entries in row 3, 0, 0, negative 37. So, distribute this negative 1 over 37. It's just 0, 0. Then, negative 1 over 37 times negative 37, 1. So, this is the new entries in row 3. New entries in row 3, 0, 0, 1. Then, copy the first two rows again. 1, 3, 2, 0, 1, negative 22. So, this is the REF form. REF. Okay, 1, 3, 2, 0, 1, negative 22, 0, 0, negative 0, 0, 1. Okay. Next, the RREF. RREF, reduced row echelon form. So from this REF, the form of RREF should be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? So we must make, because we're already done with this part, right? We should have this 3, 0, 2, 2, 0, then negative 22, 0. Okay? So let's start with 3. Make 3 become 0. Okay? How? Applying elementary row operation. So we can have R1 equivalent to negative 3 R2 plus R3, R1, right? Okay? So that we have negative 3 times the entries in R2, 0, 1, negative 22, plus the entries in R1, okay, 1, 3, 2. So distribute first is negative 3. Negative 3 times 0, 0. Negative 3 times 1, negative 3. Negative 3 times negative 22, positive 66. Plus this 1, 3, 2. So 0 plus 1, 1. Negative 3 plus 3, 0. 66 plus 2, 68. Okay, so this will be the new entries in R1. So new entries in R1, 1068. Then copy the second and third row. So 0, 1, negative 22, and 0, 0, 1. 0, 1, negative 22, and 0, 0, 1. Okay, next. The next step is to make these two entries become 0. Okay? We can start with negative 22. Let's try to make this 0. By elementary row operations, we can perform. So the new row 2 is equivalent to positive 22 R3 plus R2. Okay? So that this negative 22 will be 0. So 22 times R3, which is 0, 0, 1, plus R2, which is 0, 1, negative 22. Distribute first this 22, so that's 0, 0, 22, right? Plus 0, 1, negative 22. 0 plus 0, 0. 0 plus 1, 1. 22 plus negative 22, 0. So this will be the new entries in R2. New entries in R2, 0, 1, 0. Then copy the entries in R1 and R3, 1, 0, 68, and then 0, 0, 1. Okay? So the last step is to convert this 68 to 0. Okay? So we need to perform, so the new form of R1 will be, we need to multiply R3 by negative 68. Okay? Then add it with the entries in R1 to cancel out the 68 for it to become 0. So negative 68 times the entries in R3, 0, 0, 1, plus the entries in R1, 1, 0, 68. Distribute the negative 68 here. We will have 0, 0, negative 68 plus 1, 0, 68. So 0 plus 1, 1. 0 plus 0, 0. Negative 68 plus 68, 0. So this will be the R3. R1, sorry, R1. New entries in R1. New entries in R1, 1, 0, 0. And then copy the entries in R2 and R3, 0, 1, 0, and 0, 0, 1. So 0, 1, 0, and 0, 0, 1. So this is the RREF. Okay? So this is a unique RREF for the given matrix. You cannot have any other RREF. Okay, so I think let's end here for now. Maybe I can have part 2. So stay tuned for part 2 for this same topic, converting matrices into its row echelon form and reduced row echelon form. Okay? So I hope you learned something from this video. So don't forget to subscribe to our YouTube channel so that you will be updated every time we have new uploaded videos and upcoming uh, live tutorials. So again, I will just put the links of the past live streams for this series of lectures for advanced engineering mathematics and also the actual playlist for advanced engineering mathematics so that you can watch all the old and the new videos for the subject. So thank you for watching. See you on my next live. Bye-bye.